live. Okay, so let's do a review. I'm going to do it on a separate sheet of paper. You guys can too. I'll try and go slowly. Please, for you. If you need me to slow down, say, habla despacio, por favor, okay? Or just slow down, Mr. Davies, huh? Okay, number one. So if I want to find f of negative 6, it's just plug it in, right? It's just going to be negative 6 squared minus 10 minus 100, which is probably negative 64, but you've got 36 minus 100, negative 64. Okay. Second part, f of x equals 0 is a different question. It's not saying plug in 0. Not at all. You set f of x equals 0. So we're going to go 0 equals x squared minus 100. And we'll solve. I know there has to be two answers because it's an x squared. So there's two ways to do it. One is I could factor it, 10 and negative 10, or bring over the 100 and square root it. It's whichever seems easiest to you. Lauren, what do you want to do, factor or bring it over?
I'll bring it over.
Okay, bring it over. Probably everybody agrees with you. So if I bring over the 100, I'll add the 100. We'll square root it. Okay, here we go. Veronica, how many answers? Awesome. X equals plus or minus 10. Okay? Okay, that should be a pretty easy one. 2, I've got the square root of a negative 81 minus 8 squared to negative 9. So I'm going to have some I answers. So I'll rewrite a square root of 81 times the square root of negative 1 minus 8 times the square root of 9 times the square root of negative 1, right? We know that the square root of negative 1 is I, so I'll have a 9I square root of 81 minus 8 times 3I. I'll multiply and get 24I, so I'll go to 9I minus a 24I. What's that, a 15I probably? Minus 24, yeah, negative 15I. Alright. Everybody good so far? Number 3, you want to go back? Sorry. Okay, give me thumbs up when you got it, and I'll move on, okay? Okay, number 3. And you can always borrow my paper too. If you're a better learner just to watch, and you want to borrow my paper and take a picture of it, you can, okay? 3, square root of negative 48 over the square root of 36. I need to reduce this. So I know 48 is the same thing as 16 times 3 times the square root of negative 1. And I like 16 because it's the biggest perfect square multiple. I could have used 4 and 12, but then I'd have to break it up again. Square root of 36 just goes straight to 6, okay? Plain old 6. So then I can change that to a 4 and that to an I. So I'm going to have a 4 square root of 3I over 6. And I may as well reduce my 4/6 to 2/3 square root of 3I, okay? I'm going to FOIL, but before I FOIL I have to remember, obviously, I squared is negative 1. I'm going to need to know that. So on 4, I've got my 3 minus 5I times my 2 plus 7I, and I'm going to, that times that. 6, 3 times a 7 is a 21I. Negative 5I times 2 is negative 10I. Negative 5 times 7 is a negative 35, but I squared, right? I'm going to make sure that becomes a negative 1, and I'll combine these two i's. So I'll have a 6 Plus 11i plus 35. You okay with that? Negative 1, and negative 35 makes a positive 35. Finally, I'll add my real numbers and get a 41 plus 11i. How am I doing? Okay. 5, just like our warm-up, I'll do it. 5, we have 7 over 4 plus 5i. And Lauren asked a good question. Because it's 4 plus 5i, multiplying by 5i doesn't help. So we really have to multiply by the conjugate, which is 4 minus 5i over 4 minus 5i. On the numerator, I'll distribute 28 minus 35i. And in the denominator, 16 minus 20i plus 20i minus 25i squared. Okay, how am I doing? I'll change that to a negative 1. I'll cancel those, negative 20i, positive 20i, and let's see what I have. So 28 minus 35i over 16 plus 25, right? I think that's a 41. So I'll have 28 over 41 minus 35, 41i. You can do this tomorrow, can't you? You can do this. Thanks, Brittany. Okay, turn the page for me. All right, let's look at 6. Okay. I have 1 over I to the negative 35. Okay. So if I have a negative exponent, it needs to move. So I'm going to move it up. So I'll have really 1 times I to the 35th, okay? Now, I to the 4th is positive 1. So what I want to do is rewrite this as some I to the 4th. Some I to the 4th. So if I rewrite it as I to the 32, I to the 3rd, then that's I to the 4th, 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 which is just 1. So it's 1 times 1 times 1, which is just 1. So this becomes 1. So you get a 1 times a 1, and then I to the 3rd is negative I. Of course, that was some of the notes that Brittany gave you. Yes?
Can you explain how I to the 31st becomes 1 a little bit slower?
Yes, I will do that. So if I squared is negative 1, then I to the 4th is I squared times I squared, okay? And that's going to be negative 1 times negative 1, which is a positive 1, okay? Now, so as long as we know that I to the 4th is positive 1, I'm going to rewrite this, Ellie, you'll see it. I'm going to write I to the 4th. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, which is the same as I to 32, okay? How am I doing, Ellie?
Wait, what did you multiply that with the I to the 4th times I to the 4th?
Yeah, so when you multiply, you add exponents, right?
Oh, right. Yeah.
Right? So I know this is 1 times 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 1. So I to 32 has to be 1. So what we really have then is, back up to here, we have this is 1, correct? And then we have I to the 3rd. Now, I to the 3rd is not 1. I to the 3rd is a negative I. So what I have, let me go back to here. What I have is a 1 times a 1 times I to the 3rd, but I to the 3rd is a negative I. So what we really wind up with is a negative 1 I is my answer, okay? Great question. I think it clarified it when I wrote all the i's, didn't I? Yeah, I'll wait for you. So I just find with the exponents, any multiple of 4 will automatically become 1. And then what's left over, my remainder, is going to be my answer, okay? Thank you, Brittany. All right, let's take a look at 6. Factoring, okay, 6, I've got a 5x squared equals 10x plus 40, right? So I'm going to bring over the 10x, and I'll bring over the 40. So I'll have a 5x squared, subtract 10x, subtract 40 equals 0, okay? Now, I see right off the bat that I've got multiples of 5s, right? Everybody agree? And the cool part about equals 0, you don't even have to factor out the 5. You just divide the 5, because it equals 0, right? So we just go straight to divide everything by 5, only because it equals 0. It really makes it easier for me. X squared minus 2x minus 8 equals 0, right? I'm going to factor. I'm going to go x minus 4, x plus 2, because they'll multiply to make negative 8, but then they'll add to make the negative 2. But that's not the answer because we're solving. So if we're going to solve, I'm going to rewrite this as x minus 4 equals 0. And x plus 2 equals 0, right? Plus 4, x equals 4, minus 2. Okay. How's that? Okay, thumbs up. All right. And keeping my work over here if anybody wants a picture of it later, okay? All right, let's take a look at number 7. Completing the square, right? And you guys are actually pretty good at completing the square. Mr. Massey will be very happy if you ever take calculus, okay? All right, so x squared, this is number 7, minus 10x equals negative 12. So the first 2 steps have been done. I gave you a pretty simple problem. I mostly want to make sure you know how to do this. So we're going to take half of negative 10, which is negative 5, and we're going to square that and get a positive 25, right? So step 1 was move c to the other side. Done. Step 2, divide out the value of a. There is no a. Done. Step 3 said take half of b and square it. Half of negative 5 is, half of 10 is negative 5. Negative 5 squared is 25. But I have to balance my equation. So I add to the other side. Now this will factor. Factors into x minus 5 equals 13, or x minus 5 quantity squared equals 13. Square root, both sides, 2 answers, right? 2 answers. When x minus 5 equals plus or minus the square root of 13. Plus 5, x equals 5, plus or minus the square root of 13. How's that? So Kai, you can see that's a question where I'd want like maybe worth 2 or 3 points just because of the work, right?
Yeah, just show.
Yeah, just show the work, which is great because if you know what you're doing, but you make a little mistake, you still get most of the problem right, which is the way it should be, right? Okay, 8, quadratic formula. I've got a 2x squared plus 6 equals 5x. So to do this, first of all, negative b plus or minus square root of b squared minus 4ac all over 2a. I better bring the... Yeah, there you go, thanks. Exactly. Kai, you should be teaching, not me. There we go. He's like, no, thanks. Minus 5x plus 6 equals 0, right? And there's your a, your b, and your c. So negative b, which is a negative negative 5 plus or minus square root of negative 5 squared minus 4, because that's part of the formula, times a, which is 2, times c, which is 6, all over 2 times 2, which is 8. Okay? Now it's just not making a dumb mistake, and we got it made. Okay? So 5 plus or minus the square root of a positive 25, negative times a negative. What's that? Minus 48 all over 4. 25 minus 48 is negative 23. 5 plus or minus the square root of a negative 23 all over 4. So we're going to have an I answer. We're going to have a complex answer. 5 plus or minus the square root of 23i over 4. Leave 23 as 23, okay? Unless we're doing a story problem and we need to know a value, that is the exact answer, okay? Mathematically, 5 force plus or minus the square root of 23 force I is the answer, okay? Don't give me a decimal for the square root of 23. That's more accurate right there. All right? Okay, piece of graph paper. Okay, let me get a piece of graph paper out for this next one. Okay. All right, number 9. All right, here we go. We're gonna get this done. All right, number 9. Y equals 2x squared plus 7x minus 15. So first of all, line of symmetry. We are going to put x equals negative b over 2a, right? We're going to go x equals negative b over 2a for my line of symmetry. Or x equals negative 7 over 2 times 2. Negative 7 fourths, which is what? Negative 1.75? No, 7 fourths. 7 divided by 4. Yeah, that's right. So negative 1.75. Okay, that's my line of symmetry. So my vertex lies on the line of symmetry. So to find the vertex, it is negative 1.75 something, but I'll plug the negative 1.75 in for x to get its corresponding y value. Y is equal to 2 times negative 1.75 squared plus 7 times a negative 1.75 minus 15. Okay, clear. I'm going to go 2 times negative 1.75 squared plus 7 times a negative 1.775. Subtract 15, and I get an answer of negative 21.125. And that's my vertex. Okay. I got my line of symmetry. I've got my vertex. Got my line of symmetry. Now, the y-intercept is easy. Negative 15. Everybody agree with that? The y-intercept it's got to be 0, negative 15. It's just the value of c. The x-intercepts, will it factor? Gosh, I hope so. I don't know. I have not done this problem in a long time. If it won't factor, I have to use the quadratic formula. Just give me a second. Let's see if it does. 2x, x, 5. Yeah, it will factor. Yay, factors, yay! That's why I like factoring. 5, 3, plus, minus, because there's my 10. You see my 10x? My negative 3x makes my 7, right? Awesome. I don't have to use a quadratic formula. So I can use my mini equations. I can have 2x minus 3 equals 0 and x plus 5 equals 0. So much nicer when it factors. So plus 3 divided by 2, I get 1.5 or 3 halves. Minus 5, I get negative 5. Okay, let's put it all together. So these are my x-intercepts, 1.50 and negative 5, 0. Let's graph it. How far do I have to go down? Negative 15. Well, all right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, maybe we'll go by twos. Negative 2, 4, 6, 8, negative 10, 12, 14, negative 16. Okay, I'm just going to go by twos. I'll go by ones over here. 1. I'm just going to change scales. Okay, let's see what I have. I have negative 1.75 is my line of symmetry. So it's going to be going right down the middle, right? Here's my line of symmetry. My vertex, it's negative 21, huh? Okay, that's okay. I went by twos because there's 16, 18, negative 20. So my vertex is down here somewhere. Down here somewhere, right? Let's see. I'm going to have also a y-intercept at 0, negative 15. That's going to be right about, let's see, 10, 12, 14, right about there. Of course, I'll have another point over here somewhere. X-intercepts, 1, 2, 3, 1.5. And 1, 2, 3, 4, 5. And there it is. Yeah. Awesome. That's a big problem, isn't it? It's a big problem. Okay. All right. Give me thumbs up. I'll wait for you, okay? And then we'll go on to the next one. Okay. And then on the last one, number 10, I'm going to get my calculator out. Tell me when you're ready. And I'm going to turn the page. So scatter plot. So I'm just going to do a scatter plot just like I did yesterday. I'm going to go ages. Maybe I'll go 10, 20, 30, 40, 50. Ellie, maybe the data's going to fit better today. Who knows, right? Time, let's see. These are a little bit faster. Oh, that's because they're 200-meter dash. No, they're faster. That makes sense. Going half its distance. Okay, so let's see. What's the lowest? Be 28. So maybe I'll start at 25. Maybe I'll start at 25, 30, 35, 35, 40, 45, 50, 55. All right, so a scatter plot, 13-year-old at about 45, 15-year-old.
Could you move your graph, please?
Oh, yes. There you go. Yeah, you bet. 15 at 35, 18 at 28, 25 at 25, that'd be Kai running. That's a good time. 25?
When did I get when I ran the cast?
Probably about that. 24. I think you ran 24. Yep. 34 and 32. And age 50 and about 49. Okay. Now, there could be a parabola, right? So I'm going to go to scatter plot, right? I want to edit. I'm going to clear my lists. And I'll put my times in list, my age in list 1, 13, 15, 18, 25, 34, 49, right? And list 2, 45, 35, 28, 25, 32, 50, right? Go back to stat, calculate my quadratic regression, and there we go. There's my answer. So we're going to write this as 10. My equation is y equals I'll round up a little, 0.06 x squared minus a 3.37x plus a 73.9. Okay. Now, what age would be the fastest? Use our vertex. It's got to be in between 20 and 30, right? So negative b over 2a, right? Negative b over 2a, which would be a negative 3.37 over 2 times a 0.06. Use my calculator real quickly. I'm going to go 3.37 divided by 0.12, about 28. So about 28 years old. And that time, I'll plug it in. And so I'll take my 0.06 times my answer squared minus, minus 3.37 times my answer. Back up. Answer, and then plus 73.9. And I get a time about 26 point, boy, again, that doesn't make any sense, right? 26.5. So once again, it's not very good data, is it? All right, go ahead and say it, Ellie. Doesn't make sense, right? Because this person is slower than this person. But you can see they don't have enough data really to get a really good curve. What I would need to do, if it was a true experiment, I'd need to get more people to run it, right? And time more people, okay? All right, so that is that. All right, let me go ahead and pause that.